Ooh. So now we're going to learn about mutually exclusive events, and this is going to be our little last box with a circle in it. So remember, we had this box with a circle in it, we had this box with circles in it, we had this box with circles in it, now we have this box with circles in it. And again, remember what the box is. The box is the sample space, and remember what sample space is. I have this up over here so you can remind yourself, right? Just the terminology associated with probability. So we have this sample space, and a sample space is all possible outcomes or all sample points, any outcome that can occur when we do an experiment. And then an event is going to be a subset of the sample space. So here's an event, it's a subset of the sample space. And then the complement of the event is everything which is not this event that's been defined. So event A is this subset of the sample space. The complement is everything that is not event A. And then we have the intersection of events. And we also had the union of events. And we learned about how when we add this event with this event, whether it's the total quantity of something or the probability of each event, then we have to subtract the intersection to get what is the combined number of these things or the combined probability of these things. We have to subtract the intersection. And then here we're going to learn about mutually exclusive events. So two events are said to be mutually exclusive. So this is a common phrase. I don't know if you've ever heard it, but mutually exclusive means that if something exists, let me just give you an example. Let's ask ChatGPT, actually. My brain's a little bit in neutral. Please give me 10 funny examples of mutually exclusive. Examples to illustrate the phrase mutually exclusive and keep them safe for a college audience, for a professor to share with a college audience. 10 funny and safe examples, mutually exclusive. Pizza with pineapple versus pizza without pineapple. Okay, early bird versus night owl. You could be an early, I guess you could be both of those. You could be a short sleeper. Studying for finals versus binge watching TV. Introvert versus life of the party. Cats versus dog. You could be a cat or you could be a dog, but you can't be both. Doing homework versus doing literally anything else. Chocolate versus. So these aren't my favorites, but a mutually exclusive would be like, I can't be in two places at once. That's mutually exclusive. If I'm at home, I can't be at school, right? Those are two mutually exclusive events. Or like, I can't buy, I can't spend all of my money and still have money in the bank. Mutually exclusive. They're kind of lame examples, but you get the idea. I can't be riding my bike and maybe I was going to say on an airplane, but if you have your own airplane, maybe you could do that. I can't be talking to somebody on my phone and giving a lecture at the same time. Like, to do those both well, they're mutually exclusive. So a mutually exclusive event is when one is occurring, the other one is not occurring. So two events are mutually exclusive if when one event occurs, the other cannot occur. So if this is our sample space, right, and in our sample space, there's this subset right here, or there's this subset right here. So if this one is the one that through probability occurs, then these things are not occurring over here. And if this is the one that occurs, then these things are not occurring over here. And so that's mutually exclusive events. And if we were to add up the probability of each of these, like what's the probability that A or B will occur, we just add up the probability of A and the probability of B, and we no longer have to subtract the area where they overlap because there's no overlap, right? Like, these are not mutually exclusive. You could be in both drama and science clubs, right? And you could be in both. And so they overlap. They have intersection. But here, if you can only choose one club, you could be in drama or you could be in science if this was the way the school was. And there's no overlap. So what's the probability that you're in drama or science? Students in drama or science, you'd add these two up and you don't have to subtract anything. So those are some examples. So here is like I want to show you the definition that ChatGPT gives for mutually exclusive, which is right here. And so it's pretty much everything I just said. And it says that, hey, there is no intersection, right? So if A intersection B is equal to 0, which is here, there's no intersection. The intersection of A and B is 0. So there's nothing, right? So mutually exclusive events that cannot occur simultaneously. If one event happens, the other cannot. Mathematically, A and B are mutually exclusive if the intersection of A and B is equal to 0, meaning their intersection is the empty set, no outcomes in common. And so here's an example just to illustrate mutually exclusive events. You have a deck of cards, and event A is you draw a king, and event B is the queen is drawn. Are these events mutually exclusive? The question, are these events mutually exclusive? And what is the probability of drawing either a king or a queen? So you have to identify the events. Event A, draw a king. Event B, draw a queen. There's 4 kings in the deck, 4 queens in the deck. Determine if the events are mutually exclusive. Mutually exclusive events cannot happen at the same time. In this case, a single card cannot be both a king and a queen. Therefore, A and B are mutually exclusive. The probability of drawing a king is 4 out of 52. There's 52 cards in a deck. And that's the same as 1 out of 13. And the probability of drawing a queen, event B, is also 4 out of 52 or 1 out of 13. So what's the probability of the union of events A and B? Since the events are mutually exclusive, the probability of drawing either a king or a queen is simply the sum of the individual probabilities. So 1/13 plus 1/13 is 2/13, which is 15.38%. And so, you know, this formula here, what I want you to recognize is exactly the same as this one up here for the union. It's probability of A, probability of B. And down here, probability of A, probability of B. But up here, for a union, right, so this is for a union of 2 events, we have to subtract the intersection, right, because both of those events overlap. So we subtract here so we don't do double counting. We subtract the intersection. But because these don't overlap, right here with mutually exclusive, there's no overlap. So over here, right, with the union, we subtract the intersection. A, probability of A plus probability of B minus the intersection of A and B. But down here, there's no intersection. So we just do the probability of A plus the probability of B if we want to find out, you know, the probability of one or the other happening. So that's the 4 boxes of different ways we could kind of think about. It's a framework for thinking about an event within a sample space. And a sample space is all possible outcomes with all the sample points. And an event is a subset of that sample space. And so we have the complement of the event. We have, like, if we have 2 events, we could have the intersection. And if we have 2 events, we could also have a union, in which case we have to subtract the intersection. And if we have 2 events, they could also be mutually exclusive. So if we wanted to find the probability of one or the other occurring, we just add both those up. It's all kind of intuitive when you think about it or hear it explained, like I just explained it. Hopefully that makes sense to you. But that's those are the 4 different ways of, you know, thinking about probability relationships. Sample space with some event or multiple events defined in them. There's the complement of an event. There's the union. I'm going to do it like this. The book does the union first. I like doing the intersection first. So there's the complement of the event, an intersection of 2 events, a union of 2 events. And I like doing intersection first because when you get to union, you have to subtract the intersection. So if you don't know what an intersection is, how can you understand what you're doing in a union? And then mutually exclusive events, right? So that's mutually exclusive events. See you next time.